Hello guys, this is Alan Paul, UR16CS006, and today we're going to do our 10th experiment and 10th and the last experiment in our system software and compiler lab, which is for intermediate code generation. So the aim of the exercise or the experiment is to write a program to convert the given arithmetic expressions to three address codes. So uh, I'll just read out the description first and then we'll explain. So the description is the compilation process can be divided into a number of substates or tasks called phases of the compiler. Once the once the syntactic constructs are determined, the compiler can generate object code for each construct. So we know there are very many different states of a compiler. These states, the different states of a compiler are like analyzing analyzing or the front end of a compiler. We have different states like lexical analysis, syntax analysis, semantic analysis, intermediate code generation. Then we have the code optimization where we'll get the three address code, and then we have the code generation using the three address code. So the different phases, like are the different phases where syntax analysis, also termed as parsing, where the stream of tokens is reconstructed based on the context free grammar given, and then we have type it performs checking, etc. So one by one we have all completed the phases of of a compiler. We have done lexical analysis, we have done syntax analysis, we have done semantic analysis, we have done intermediate code generation, and then we have done that we are doing, and then this experiment is for the intermediate code generation. We have also done a program to determine the symbol table or add to the symbol table. So in this program we'll do this intermediate code generation. So here we have the program. uh, uh, as the compiler creates an intermediate form, it helps in code optimization, and also it makes a clear act separation between machine independent phases and machine dependent phases. So as the program goes on, as the compilation on the as the code optimization goes on, the compiler also differentiates between the machine dependent and independent phases. So one form of intermediate code is a parse tree. So parse tree, parse tree that we have, like the parse tree that we construct, is a form of intermediate code. A parse tree may contain variables as the determined codes. Another form of intermediate code is a three address code. Three address code is what we have to make using this program. So like we have to three address code, we have to generally, like, if in what happens in a three address code is we'll be generally given will be given an equation, and then we have to create the equation into a proper statement. Like we have to state what is happening in the equation. So here we have the program. So like it's a 10th program. We have the necessary input util files, Java files, and then here we have the scanner as new scanner system string. We take the string. We have the strings that inputted strings into the string array. We have the array as a. It is an array A of size 20. So we'll enter plus, minus, multiply, divide, percentage, power, etc. And then we have another array M for new string of size 10, N, another array of N, which is initializes N, which contains T0, T1, T2, T3, T4, and T5. Then we are initializing count to 0. Then we'll ask the user to enter the input. In is equal to s dot next. So we'll once the user enters the input, will give the user the will give the user the subsequent three address codes. So this is we are calculating the three address codes. We are taking in the length and the opcode length, and then we are giving out the necessary required three address code. So we can try running this program. So it is asking us to enter the input. So the input will be a basic arithmetic equation like 5 plus 10 plus 20 minus 2 or anything like that. So we'll just enter a arithmetic equation as 5 plus 6 into 8, and then we'll have minus 2. So we can see that the three address code is generated. So the first code we have, it is dividing our equation into three parts. We have T0, which is 5 plus 6, and then the answer in T1, the answer of T0 will be multiplied with 8, and in T2, finally we'll subtract the answer of T1 from with 2. So like we'll divide each of the state or each of the equation that is happening in the whole equation into parts. So the first equation, that will be 5 plus 6, it will be added. Then the then after adding, the equation is multiplied by 8. Then after that we'll subtract the equation by minus 2. Thus we have completed our experiment successfully.